So in this video I'm going to explain you the electrolysis of acidulated water. In the previous class we have completed electrolysis of molten lead bromide. So today we'll discuss electrolysis of acidulated water using platinum electrodes. In the previous video we used carbon electrodes. So in this video, for this electrolysis of acidulated water, we have to use platinum electrodes. Now do you see this apparatus? So this is the apparatus for the electrolysis of acidulated water. This is your cathode. See here, platinum gauge is placed here, and this is your anode. So this is your glass. So here water is introduced. So first the level will be similar. Now the water cannot conduct electricity. It is consist of molecules, so water do not conduct electricity. So few drops of sulfuric acid is added here in this water. So sulfuric acid will act as a catalyst for electrolysis of acidulated water. That is the meaning of acidulated water. Water has few drops of sulfuric acid. We cannot use other acids. The reason is because the other acids are volatile. Volatile means they easily vaporize. So sulfuric acid, dilute sulfuric acid is non-volatile. They do not evaporate easily. So here are few points. The electrolyte. So what is the electrolyte present here? The electrolyte present here is water plus acid. So it is written as acidified water. That is water plus dilute sulfuric acid. Other acids are volatile and are not used. Point 2. Platinum foils are used as electrodes. Water do not conduct electricity. So few drops of dilute sulfuric acid is added for ionization. The sulfuric acid acts as a catalyst. So due to the presence of sulfuric acid, the ions present in water, that is hydrogen and OH ions, will dissociate. So I'm going to show you a small video. Here you'll understand it. Okay. So this is the apparatus. One is your cathode and the anode. And it is connected to the battery here. This voltmeter, ampere. Now the electricity will pass through them. So you will notice tiny bubbles coming out from both the anode as well as cathode. Now these tiny bubbles, I'm going to explain you what are these. One is your oxygen and the other one is your hydrogen. Now these gases are collected in such a way that first the water level will be same. Then after some time you will notice the level of water is different. So let me show you here again. So okay, look, the level of the water before the electrolysis of acidulated water was similar, but after the electricity passes through them, you will find this gap. Now this gap is actually a volume. Here, look at the volume. Now which volume is more, left hand side or right hand side? Left hand side. So here actually hydrogen is formed. Hydrogen is positively charged ion, and this left hand side we have cathode. So hydrogen ions get collected at the cathode. So this is actually a hydrogen gas getting formed. Whereas on the right hand side is less, that is your oxygen. Now how to test which one is oxygen and which one is hydrogen? That's what we're going to look. So at the end, a valve is opened here. So now water level will be normal, will be same, and here a gas is collected. So it is closed here, the gas. So on the right hand side, this is your anode. So here also the gas is collected by using the valve. So the gas is collected in the test tube. Now the water will be same level. Now to conduct this. Now this is your actually hydrogen. Hydrogen is getting collected at the cathode. Now when this hydrogen burns in presence of flame, it makes a popping sound. Let's see whether that works here.
Cracking sound proves that the gas released at the cathode is hydrogen.
Make a popping sound. It makes a pop sound. Now oxygen, it supposed combustion. So if you bring a burning splint, it will start to glow. So what does this prove? It proves that this is your oxygen. So this is your acidulated, electrolysis of acidulated water. So I'm going to show you how we are going to write this. So what are the electrolytes? The electrolytes present here is water. So I'm just going to write short form W. I'm going to write here full water. So what kind of water is this? Acidulated. So water plus, you can write sulfuric acid here, dilute sulfuric acids, H2SO4. So how we are going to find out what are the ions present in acidulated water? So we are going to write ions present. So first of all, we have sulfuric acid, H2SO4. Now this sulfuric acid has how many hydrogens? It has 2 hydrogens, isn't it? So it is positively charged, hydrogen, 2 hydrogens. And we have anion, these are cations. We have sulfate as anion, -2. Then we have water, H2O. Now this also I'm going to write here 2 times, because there are 2 hydrogens here. That's why 2 hydrogen ions here along with its ion, cation. Then we have OH ions. So what we are going to do here is, we are just going to break this hydrogen. One goes out here, and what happens to the another hydrogen? Now that actually forms here OH ions. So do you see the ions present here? So what are the ions present here? We have hydrogen ion. We don't have to write 2 hydrogen ions, okay? Then we have sulfate ions. Then we have hydroxyl ions. So these ions we are going to write over here. So we have done the ions here. So what are the ions present? Hydrogen. Then we have OH ions. It's negative. Okay. Then we have sulfate. Now if you compare these anions, now we have 2 anions, negative ions here. So out of these 2, which ions, negative ions, will be attracted towards the anode? So which ion will go towards the anode? Actually, both the ions goes towards the anode, but only one of the ions will take part in the electrolysis. So we are going to look at the table. So here we have selective discharge of ions, fluoride, sulfate. Now look, where is sulfate? Sulfate is on the top. And where is OH ions? OH ions are at the bottom. Now which ions will be discharged more easily? OH ions, because down the group the discharge of ions increases. So OH ions will go towards the anode compared to the sulfate ions. Now these sulfate ions will remain at the bottom, okay, but OH ions will be discharged. So here which will take part? Only OH ions will take part in the electrolysis. So these are our ions present here. Now we are going to write the reaction at the cathode. Now always remember, cathodes are negatively charged, anodes are positively charged. So what happens here? Now here at the cathode, what you are going to do is very simple. Hydrogen will go towards the cathode, isn't it? It is positively charged. So hydrogen. So 4 hydrogens. Now this you have to mug up. Now 4 hydrogen. Now 4 hydrogen. Cathode means what happens at the cathode? Oxidation or reduction? Oxidation means losing of electrons. Reduction means reduction is gaining of electrons. Oxidation is losing of electrons. So cathode, you have to write here plus. So gains how many electrons? 4 electrons. After gaining 4 electrons, this will be neutral. So what we are going to write here is, we have 2 hydrogens. So 2 volumes of hydrogen is released. So you can see here, on the left hand side we have cathode. So that's why here we are having oxygen. So here if you compare the volume, look at the volume. Look, it's 2 volumes. It is double the volume of this product, oxygen. That's what we are going to do. So this happens at the cathode. Now what happens at the anode? Now at the anode, what you're going to do here is, anode loses electrons, isn't it? So at the anode, which ion will go? Hydroxyl ions, because we checked in the table, OH ions are at the bottom, so this will be discharged. So here what you need to do is, just you write 2 OH ion. Now this you have to remember, 2 molecules or 2 atoms of hydroxyl ions combines with other 2 hydroxyl ions, it loses its electron and it gives 2, I'm going to write here at the bottom, so it gives 2 molecules of water and 1 molecule of oxygen. So here you can balance it. How many oxygens are there? 2 plus 2, 4. Here also we have 4 oxygens. How many hydrogens? 4 hydrogens, 4 hydrogens. Now do you see this oxygen? Now this oxygen is actually getting evolved at the anode. This is your oxygen gas. This is your acidulated electrolysis of acidulated water. So overall reaction, how you are going to write? So overall reaction will be 2 molecules of water. So after conducting electricity, you can write here electrolysis will give how many oxygens are here? Only 1 molecule. And how many hydrogens? 2. So 2 volumes of hydrogen gas and 1 volume of oxygen. So this is our overall reaction of acidulated electrolysis of acidulated water.